A light pole is classified as a structure primarily because of its permanent nature and intended function. It's designed to be a fixed installation anchored to the ground to provide support for a lighting fixture. This permanence is a key factor in determining its structural status from an electrical code perspective. The electrical code, such as the National Electrical Code, often abbreviated as NEC, has specific requirements for grounding structures to ensure safety and prevent electrical hazards. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and de-energizing the circuit. This helps to minimize the risk of electric shock and fire. A permanently installed light pole is typically subject to these grounding requirements because it's considered an integral part of the electrical system. The NEC addresses the grounding and bonding requirements for structures in Article 250. This article provides guidelines for ensuring that metal parts of electrical equipment and structures are properly grounded to minimize electrical hazards. Grounding a light pole typically involves connecting a grounding electrode conductor, often abbreviated as GEC, to a grounding electrode system, which may consist of ground rods, ground plates, or the building's metal frame. The size of the grounding electrode conductor is determined by the size of the service entrance conductors or the equivalent. Bonding, on the other hand, involves connecting metal parts together to create an electrically conductive path. This helps to equalize the voltage potential between different metal parts, reducing the risk of electric shock. Bonding is often accomplished by using bonding jumpers or conductors to connect metal enclosures, raceways, and other metallic components. Now consider a spar. A spar, in contrast to a light pole, is generally considered a portable or semi-permanent structure. While some spars may be permanently installed, many are designed to be moved or disassembled relatively easily. This portability is a key factor in determining whether or not it's classified as a structure requiring grounding in the same manner as a light pole. The electrical code typically differentiates between permanently installed and portable equipment when it comes to grounding requirements. Portable equipment, such as spars, often relies on equipment grounding conductors within the power cord to provide a ground fault path. This means that if a fault occurs within the spar, the fault current will flow through the equipment grounding conductor back to the source, tripping the circuit breaker or fuse. Some spars may also require ground fault circuit interrupter, often abbreviated as GFCI, protection to further enhance safety. A GFCI is a device that monitors the current flowing in a circuit and quickly interrupts the power if it detects a ground fault. This helps to prevent electric shock by cutting off the power before a person can be injured. The NEC provides specific requirements for the installation and wiring of spars and hot tubs in Article 680. This article covers topics such as bonding, grounding, GFCI protection, and the location of electrical equipment near the spa. Section 680.42 specifically addresses the wiring methods for spas and hot tubs, outlining the requirements for underground wiring, bonding, and GFCI protection. It's important to note that even though a spa may not be considered a permanent structure, it still needs to be installed and wired in accordance with the electrical code to ensure safety. This includes proper bonding of metal parts, GFCI protection for outlets and equipment near the spa, and the use of approved wiring methods. The absence of a requirement for a grounding electrode for a spa doesn't imply a lack of safety measures. Instead, it reflects the different electrical characteristics and installation methods associated with portable or semi-permanent equipment. The equipment grounding conductor in the spa's power cord, combined with GFCI protection, provides adequate safety in most situations. Therefore, the distinction lies primarily in the permanence and intended use. Light poles are fixed, permanent installations subject to structure grounding rules. Spas, being portable or semi-permanent, adhere to different grounding protocols, often involving equipment grounding conductors and GFCI protection. To reiterate, firstly, a light pole is a permanently fixed structure meant to support a light fixture, necessitating grounding as per electrical codes to prevent hazards. Secondly, a spa is typically portable or semi-permanent, allowing it to adhere to different grounding protocols. Thirdly, SPAs usually rely on equipment grounding conductors and GFCI protection instead of requiring a direct grounding electrode. Fourthly, NEC Article 250 provides grounding and bonding requirements, while Article 680 specifically addresses SPAs and hot tubs. Fifthly, grounding provides a fault current path to trip a breaker, reducing shock and fire risks. Sixthly, bonding connects metal parts to equalize voltage and further minimize electrical hazards. Seventhly, the size of the grounding electrode conductor, often abbreviated as GEC, is determined by the size of the service entrance conductors or the equivalent.